Everybody, we're going to get started. This is Adam Culp, and he's going to be talking to us today on refactoring legacy code. And we'd also like to thank all our sponsors that are making this conference possible for us. And you've seen their booths downstairs, but it's Xmission, MongoDB, MySQL, and a bunch of others. So thank you, and I'll turn the time over to you now.
Thank you. Appreciate it. All right, countdown's going. All right, thanks. Welcome. We're going to talk about refactoring legacy code. Now, this is not my refactoring talk. I am known for my refactoring talk, where I talk about the basics of refactoring and the step-by-step ways of refactoring. This talk is not that. However, we are going to talk about modernizing your legacy code base or refactoring your legacy code base. Most of you are probably here because you have a legacy code base, or you fear you may work with one someday. So we're going to go ahead and get started. As you said, my name is Adam Culp. You can find me on Twitter at Adam Culp. Please feel free to follow, ask me questions, or if you need any other advice or anything, please feel free to tweet to me. I appreciate any feedback you can give me based on this talk. Please leave me feedback. This is talk 16639 on Joined In. Please leave me feedback afterwards. I talk at a lot of conferences. I speak at about 13 to 15 conferences a year. The problem is not getting me to talk. The problem is getting me to shut up. But that being said, please leave me feedback, because I take that feedback that I get from all the conferences and I tweak my talks so that way the future audiences will benefit from that. So please share your ideas for the talk or any feedback you want to give me. A little bit about me. I'm a PHP 5.3 certified engineer. I work for Zen Technologies. I'm a consultant with Zen. I don't sell Zen products per se. I'm actually a consultant that goes out and helps companies refactor, helps companies modernize their legacy code base, create clean architectures, and things like that. So I do a lot of true consulting. I'm not really selling Zen products. If Zen products happen to fit the need of the customer, by all means, I'll mention it while I'm consulting. But my job is to help companies create better code and create better applications. So if your company has any needs, please give us a call. I'm also on the Zen Certification Advisory Board. I help with the PHP 5, with the PHP certifications, as well as the Zen Framework certifications. I help create the questions for those exams. I'm also the organizer of the South Florida PHP user group in from Miami up to West Palm Beach area. We have about 800 plus members for a user group, and I also organize the Sunshine PHP conference, which is coming up in 3 weeks. So there's a lot of worse places you could be than Miami in February, right? So that's coming up in 3 weeks. We're looking forward to that. We're almost sold out of tickets. There's a few available. I'm a long-distance ultra runner. I'm not currently running a lot because I injured my shoulder a couple weeks ago snowboarding. But that being said, I am an ultra runner. For those of you who don't know what that is, a marathon is 26.2 miles. Ultra means more than. So I run more than 26.2 miles. I'm currently trying to achieve 100 miles. I've gotten up to 100K officially, and I've gotten as high as 72 or 73 miles in an attempt to get 100 miles. I haven't achieved 100 miles. And it looks like I'm going to be, because of my injury, I'm going to be detained on that a little bit longer. I'm also a judo black belt instructor. I teach a lot of kids in South Florida about judo and the practices there. Now I bring up some of these things because all of them require iteration. I'm a huge fan of iteration. I love iteration. It's our life as developers, right? We iterate over our code. We iterate over our projects. Long distance running, I didn't just jump off the couch one day and say, I'm going to go run 100 miles. It takes practice. It takes training. It takes learning all the nutrition and all the other things that our bodies need in order to be able to run those types of distances. Judo, everybody knows that martial arts is a lifelong study. We get better at it over time. It's iterative. Evading project managers, that's iterative. We get better at it as we practice that. Development and refactoring, much the same thing. They're iterative. It's not something, you don't just sit down to your application and refactor. You don't modernize your application, which is what we're talking about here, in one step. You do it iteratively. You do it in small little increments to eventually get your code base cleaned up and make it really nice. Now this talk is based on a book from a good friend of mine, Paul M. Jones. If you haven't heard of Paul M. Jones, this is a great book. The website is MLAPHP, which is short for Modernizing Legacy Applications, PHP. Paul wrote this book, and it is a step-by-step guide of how to modernize your legacy application. This talk is also going to walk through those steps, but it's not as detailed as the book. I'd encourage you, if you have a legacy application that you need to modernize, this is a great investment. I also wrote the foreword for this book, so at least read that. Now, what is legacy code? If you're, is there a coding standard in your project? If you have a coding standard in your project, then, or if you don't have a coding standard, then you might be dealing with legacy code. Are you using object-oriented programming in today's modern applications? Now, granted, I do a lot of programming procedurally. I don't do all my coding object-oriented. But, and for a full application, generally, I'm going to use object-oriented, so that way I'm not repeating and I'm following a lot of today's best practices for that. Are you using Composer in your project? How many people have not heard of Composer? Okay, good. I was hoping I wouldn't see hands. So Composer, if you're not using Composer. Also, using a framework is vital in today's applications. If you're not using a framework in your application or your projects, please use a framework. Please save yourself that trouble. Don't recreate the wheel. Use a framework. And by all means, don't use your own framework for your employers or for your enterprise applications. I might talk more about that a little bit later if we have some time. Are you doing unit testing? Does your project avoid not invented here? Meaning using frameworks and other libraries and things like that. If you can answer no to any of these questions, chances are you are working in a legacy application, or you may even be creating a legacy application as you go. So please, follow some of these practices so that way you're not creating a legacy application from the beginning. The idea is to make that better. So, a little bit about refactoring. According to Wikipedia, refactoring is the process of changing a computer's programming source code without modifying external behavior. So in a sense, we're not adding any functionality when we're refactoring. We are simply cleaning up the code, making the code quality better. As we develop, I attribute it to wearing two hats, right? We have a coding hat, we're adding functionality, we're creating new code, and then we switch over to our refactoring hat, and when we have our refactoring hat, we're cleaning up. We're fixing the code. We're not adding any more functionality at that point. These are two separate operations. If you mix them, you will end up in difficulties. You will end up with more bugs, and you will end up with a lot more problems than you really need. So I encourage you, please, do those as two different things, right? So we code, then we refactor, then we go back and we code some more, and we refactor as needed. After you're done with all that, then we worry about optimization. Refactoring is not optimizing. Granted, it might be refactoring the code, it might be more optimal, and you may gain some optimization out of refactoring, but refactoring itself is not optimization. There may be times where after you finish refactoring, you need to go back and optimize the code. You might even have to undo some refactoring and find a more creative way to do it. It's rare, but it happens. So with that in mind, don't have optimization in mind while you're refactoring. That is not refactoring, it is a separate thing. Also, as we're modernizing our applications or refactoring, we want to make sure we have source control of some shape or form. We should be using source control in all of our projects. Every time we touch code, it should be versioned somewhere. It should have some repository somewhere where versions are kept. So that way we can gracefully roll back if we need to. We can figure out where we might have made a mistake. We can, it gives you infinite functionality as far as being able to work with your code. I personally don't care what version control system you use. There are many out there. Git, Subversion, Mercurial, SourceSafe from Microsoft, and a bunch of other ones. Doesn't really matter what you're using, use something. And by use something, I don't mean make your file names have a date on it. That is not version control. Use an actual version control application. As we're modernizing as well, another thing that I encourage you to adopt is using an IDE of some shape or form. Okay? Now, I realize there's a lot of purists out there that say, well, I use Vim, and I use this, and I use that, okay? But as you're modernizing, an IDE is going to save you a lot of trouble, because you're going to be able to do searching much easier. While you're refactoring, you're going to be doing a lot of searching. So that way you can find things in your code base a lot more easily. So I would encourage you to use some sort of an IDE, whether it's ZenStudio, PHP Storm, NetBeans, even UltraEdit, something as simple as that. It allows you to define a project. Sublime Text, it also allows you to define a project. It's considered kind of an IDE. I mean, it really is, it's an editor. It's not a full-blown IDE, but it still gives you the functionality that we need for modernization. But please use something that makes your code base more easily searchable. So that way you can find things as you need to. Another thing, pardon me?
Git grep. Find things really fast.
Yeah, I won't go there. You need to use an IDE or something along that lines. Just makes it more searchable. Anyway, so then you should also have some sort of style, right? Define some sort of style as you're modernizing and as you're refactoring. Now, I'm not saying that you have to use the Framework Interoperability Group standards. I'm saying you have to use some sort of standards in your project. This is a good starting point, and a lot of frameworks are using it these days. So if you are also using a framework, which I recommend, then your coding standard would also match theirs if you were using something like the PHP Fig. And there's a lot you can do a lot worse than using the recommendations by PHP Fig. We also want to make sure we have testing in place. If you don't have testing in place in your legacy application, that has to be your first step, is to get testing in your legacy application. Now, I'm not saying take your legacy code base and instantly adopt unit testing. You're not going to do that. All right, it's a legacy application. It's trash. You're not going to be able to introduce unit testing. Have some sort of testing, right? Even if it's just an Excel spreadsheet with step 1, step 2, step 3, step 4, here's how I'm going to test, you have to have at least that. Don't refactor, don't modernize without having that. If you have no tests, whether they're automated or not, you cannot refactor. It is not refactor. Some would say that you're not actually even coding it. You don't have tests, because how can you code if you don't know what your application is supposed to be doing, right? You have to have some sort of test, even if it's just manual tests. Like I said, step 1, step 2, here's where I click and here's what I expect to happen when I click. You have to have that. If you don't, please get that first. So in our modernizing journey, which we're going to cover now, we're going to do it in multiple steps. The first thing we're going to do is we're going to adopt auto-loading. So that way we can modernize and have the auto-loading in place. That way we're not having a bunch of require ones and a lot of includes and things like that in our code. We're going to use auto-loading so that way we can get our application auto-loading in a lot better manner. We're going to consolidate all of our classes in one place. So that way we don't have classes spread around throughout our application. We're going to clean up the use of globals. Generally, legacy applications have globals that they're using in one shape or form. We're going to clean those up. Then we're going to replace where we're doing instantiations within our code using the new, or using new to instantiate classes. We're going to then create tests, extract SQL to a place that's more usable. We're going to extract logic, and then we're going to clean up any other additional includes after that. These are the steps to modernizing a legacy application. So let's get started. First thing is auto-loading. Now, I recommend that you use namespaces. If you should be using a version of PHP that is new enough that you have namespaces, right? PHP 5.3 and 5.4 are already deprecated. They're already gone. So you should be using something new enough that you have namespaces. By the way, if you don't have namespaces in your code, you can still rely on the global namespace, which does exist. Your code is already namespaced, whether you've defined it or not. The global namespace is there, and you can use that. You can leverage it, but I encourage you to actually put namespaces in your code to help yourself. So as part of our auto-loading, we're going to use one of two different types of auto-loading. Now, there are others available, and I'm going to cover those briefly as well. But out of the gate, we want to try to use PSR 0 or PSR 4. PSR 0 is where your class names are very long, and the underscores denote slashes, so it's the file structure. So in this case, my long class name translates to /my/long/class and then /name PHP, right? And that's how the BSR0 auto-loading works, is it actually parses that out. Using BSR4, you don't have to do it that way because your class name would just be name, right? And that file name PHP would exist in that directory, but the name of the class would just be name instead of having all the underscores having to parse it out like that. So that's PSR4, that's using PSR4. I recommend using PSR4. Try to use PSR4 if you're starting from scratch and using something, use PSR4. Don't use PSR0, it's deprecated. It still exists for the folks who are stuck with those old applications that do the naming this way. Now you can also use a class map for your auto loading. If you need to, you can use a class map. So you can say, okay, all my classes, here's a list of all my classes and here's where to find them. And you can do it that way. But ultimately we want to get to this sort of way of auto loading. Yes?
When you say use, I've heard this a couple times today already. You use PSR0, PSR4, to me those are standards. So
yes.
Is there an actual auto-load function under PSR4 that I can download and use, or do I have to go write that myself?
There is. So the easiest way to do that would be to include Composer into your application, right? So you would have Composer, and then when you do a Composer install, whether it's using a class map, PSR4, PSR0, or any other mixture of auto loading, Composer is going to create that for you. And you don't have to create it, it's just there. And all you have to do is include that file into your code base, and now you've got auto loading. And we're going to kind of cover that a little bit, but yeah, great question. Great question. I recommend not creating your own auto loader. Please use Composer. Let Composer do it for you. It will save you a lot of headaches later, and it's just really darn good. So please feel free to use that. So there are different auto loading approaches. One is using some sort of global function. There's also closures. You can use a closure to do it, and do it that way. You can use static or instance method. This is preferred if possible, if you're able to do it that way. And then there's also, if you're on PHP 5.0 using the _ auto load. Again, we want to try to stick with static or instance methods, like using Composer. That's the ideal way to do it. And it's so easy to do. At first, if you are not using that, you might need to wrap your head around a little bit, but once you do wrap your head around it, it'll save you a lot of troubles, and it's very easy to implement. And there are many examples of how to do that. One project that I work on is the IBMI toolkit. We just recently started modernizing that one. I mean, we had multiple classes per file. We had some files that only had a single class, so we had to start with the class map. We couldn't go to PSR0 or PSR4. I encourage you to take a look at that repository on GitHub. That'll show you how you can start that, right? And use Composer from the beginning with that to incorporate namespaces. Like I said, we're still in the process of modernizing that. That's a 10-year-old code base. So there is some ugly stuff there. We're still cleaning it up, but it's a good example. The next thing we want to do is we want to consolidate our classes and get them in one place. That way it makes auto loading easy. If you have all your classes in one place, it makes it much easier to load them, right? Because then you can tell your auto loader, here's where all my classes are. Now, generally in a legacy code base, you're going to have classes kind of spread around. They're going to be a little bit here, a little bit there, kind of like this code base. We've got a classes folder, we've got some other places, a live folder that might have some classes in it, and some different other things. So our classes are kind of spread around. So the idea is to consolidate them and move them in one place. I'm going to show that next. So how we can find those are also by doing a search. This is where this is where our IDE comes in handy, because we use our IDE and we can search for instances of new. Right? And when you find an instance of new using that search throughout your project code base, then you can see where it's loading that class, and very quickly you realize what you need to clean up. You can find all your classes relatively easy that way. So then you want to, using that, it'll give you a good indicator. So then we can take our our classes that we have in a different location, we can move them up where we want them all centralized, and it makes it a lot easier to clean up. And then using our search feature, we can then go back and change our code to actually remove the require, because we're using the autoloader. We no longer have to have a require statement. When we say new, the application goes and finds it in the centralized location, loads it for you, so you don't have to do the require once. And it cleans up the code base that way. So that way your autoloader is doing all that for you. This is why the search is so important as we're doing this. And then we want to go back and repeat that over and over and over again until we have that all cleaned up and we have our classes all in the central location. After we've cleaned those up, the next step, now keep in mind that there are many steps to this modernizing journey. These are not small steps. These are going to take you a long time. There's going to be a lot of labor involved. You're going to hate it. But the goal is to, through that iteration of getting to a good clean code base and having everything nice and clean. The next thing we want to do is we want to try to clean up global dependency, the use of global, right? Because that's a bad thing. When you have something that's global in your code base, who's to say where something was set, right? If it's globally able to be accessed, it's globally able to be changed as well. And then when you have a bug that pops up, now you're searching through your code base to figure out where was that set, where was it changed. We don't know if it's global without doing a lot of searching. And even once you search, you're not going to find the exact place. You have to continue searching and debugging until you finally figure out, okay, where is that being set incorrectly, in the case of some bugs. So we want to search for global references. We want to look for, we want to move the global calls to the constructor. We want to convert the global calls to a constructor parameter. After that, we want to update the global calls to a class. And then we want to instantiate the new class and pass it the parameter. Because obviously if we needed something to be global, it's because it needed some arguments, it needed some data, right? That's why we made it global in the first place, or somebody did. And then we want to repeat that until we get all those cleaned up. Yes?
You can have a case where a variable is legitimately global. For example,
There's no such thing.
there is, well, there is. You can have some piece of information, let's say number of servers that the application runs on, or something like that. The name of the host. It could be legitimate.
Let me go through it. I think I'll clean that up for you, so that way you'll see that there is no such thing. I understand it's not easy. It's not easy to find those. It's not easy to wrap our head around cleaning up those globals so we don't have them. There are ways to handle data in a global sort of manner that we don't have to use globals to do it. And that's the end goal. And we want to get to a point where we're able to handle our data without making it global, and therefore, understanding where a change might have happened and things like that. Whether it's using mutability or whatever the case might be to ensure that we're not changing that data in a way that's bad, right? So I understand what you're saying in concept, but there are ways to fix that so that way we don't have to rely on globals. So step one in cleaning up, we want to search for global reference. And this could be just searching for the global keyword. If you want to clean up your super globals, so that way you can use them in a little better manner, through some framework or something like that, you would search for them. But in this case, we're just searching for the global usage. In this case, we have a database connector. Database connector is a prime example of legacy applications using a global. How else do you have your database connector available in your application without making it global? In the old days, it's the only way you could do it, right? It's the way PHP used to be. So we have the global database connector there, and then we run our query. And then down in somewhere inside the setup file or some sort of include is where that would actually be called from or created. We would instantiate our DB object, pass it the arguments, and then we would access it globally, right? So that's what we're going to clean up first. So step two, now that we know where it is, step two is we're going to move that global call to a constructor within our class, and we're going to pass values as properties. So in this case, we create a constructor in our class. We're going to keep the global DB there for now, right? and we're going to instantiate it. And that's how we're going to tackle it as a next step. After we've done that, then we can go back and we can pass it into the constructor as an argument. So now we no longer need global, right? We're going to pass it into the constructor versus have the constructor call it globally. Now, how we do that is as we call this example class, we now have to pass it to DB, right? So what we're going to do is we're going to have our, we have our require once in the setup, and that's going to carry our DB instantiation, so that way we have the DB available to pass to the example class. All right, so step by step, we've eliminated that global. Now we're passing it in using dependency injection versus using it as a global. And then we look for more instances of it and clean up the globals in that sort of way. So first we moved it into the constructor, kept it global. Then instead of using it as a global, we passed it into the constructor through instantiation of one form or another. And then we moved on and we continued cleaning. After we do that, our next target is instances of instantiation, right? Because we've done the auto-loading pieces, we want to make sure that we're replacing all instantiations of new. You know, there still might be some classes being instantiated somewhere that we didn't catch when we were initially breaking out our classes for the auto-loading. So we're going to search for all the rest of the instances of new that are out there. We're going to extract those into our constructor parameters one at a time. Then we're going to extract the block, and we're going to either create a factory if there's multiple instances of it, or if it's being iterated over, we're going to create some factories to do that and make it a lot easier to use. After that, we're going to update the instantiation calls, and then we're going to repeat this until we have all those instantiations cleaned up. So that way we don't have instantiations all over inside of our code base. We want to clean those up either inside factories or inside some way that makes more sense, makes it more centralized so we can manage it. So as an example, we have this items gateway. The items gateway, we're creating our database, right? Database connector here. We have the fields inside the class, and we're passing into the constructor, we're passing the arguments, which is good code base, good code. We're injecting those in, and then we're instantiating our database. And this is how it started. So taking it a step further, now we're going to instead inject our database into this items gateway. Now, if the items gateway is something's happening there multiple times, let's say we have a loop. Okay, so inside our items gateway, we have a select all, and we're looping over the thing. See how we're creating a new item here every single time? So we're iterating over that many, many, many times. And that gets kind of sloppy. So what we're going to do in that case, where we're repeating it multiple times, is we're going to create a factory. Inside that factory, we're going to instantiate our new item there in the factory. And then we're going to pass that factory into the items gateway. So that way our instantiation is happening in the factory and not in the items gateway. Now we can actually loop over that. After we're including it into the items, we can include the item factory into the item gateway. Then we can come in, and instead of instantiating the class every single time we call it, we're instantiating the class once in the factory, and then we're just telling it, make another item factory here inside the loop. It's cleaning it up. That was kind of fast. Did everybody see how that happened? There's a lot of good stuff there, but I'd encourage you to download this if you want to see these code samples. I also have these code samples available on GitHub. I'll share that URL with you later. Because I know for some of you who may be working in the legacy code base, some of these things may go a little bit quick for you. And I apologize for that. There's a lot to it.
What's the rationale for using a factory?
The rationale for using a factory is because then you're only instantiating one time. You're not instantiating over and over and over again.
Couldn't I just instantiate it once and reuse it?
That's why you're using the factory. You're letting the factory instantiate it one time, and then you're sharing that factory over and over again. And you're sharing that object over and over and over again. So that way you don't have to instantiate it however many times that loop calls for,
I
right?
could just keep a reference to it somewhere.
somewhere, right? But a factory is much cleaner, right? Because then it's all in the factory. Yes?
You might be allowed to say this, but another reason to do this is so that it makes testing this much easier.
Yep.
Because you're not instantiating within the test. So like when you test select all, now you can pass it your bumped instances of a factory so that you don't actually do any work while it's testing just this piece of code.
Right, yeah, very good point. Just makes it really testable because then you're testing your factory and you don't have to worry about finding the reference. You're not going to be able to test a reference, but you can test a factory, right? In an automated fashion. So after we've got to that point and we've cleaned that up, then we just repeat it over and over and over again until we've cleaned all those up. Now, by this point, we've got our application auto-loaded. We've cleaned up instantiations of new. We've gone through and cleaned up a lot of code at this point. This is not a small feat. This is sometimes months, maybe even a year's worth of work to get to this point, right? Depending on how big your code base is. I was working with Disney World, 4 million lines of code with legacy application. It took them 3 years to get to this point, following the steps to modernize their legacy code base. There's no way they were going to recreate a brand new 4 million line application. It just doesn't make sense. It was just too much money, right, to pay teams of thousands of developers to create a brand new 4 million line code base, right? So they followed these steps. It is very painful, but it is a necessary evil to get things modernized to the point where you can get here. Now, once you've got here, your code base is pretty clean. We've got a pretty nice code base at this point. So now we can go back and actually write some tests, automated hopefully, but now you can write some true tests, not an Excel spreadsheet of step 1, step 2, step 3. Now we're actually able to write unit tests because our code is very clean. We can test the entire application through automated methods. If it's not testable, then we would do other small refactors like extracting methods and cleaning some things up, replacing temporary variables with queries and things like that. And there may still need some cleanup in order to do unit testing at this point, but for the most part, our code is clean enough that we can do that in small steps, right? Because now it's a lot more manageable. Then, after we write our test, now we want to clean up some of our SQL. Generally, a legacy application has SQL strewn everywhere. It's all over the place. You have queries in line, you have queries in the middle of loops. You have your SQL, your SQL is embedded within your code. No separation of concerns there, right? So the idea is we want to take that SQL, we want to extract it out and put it in a central location. So that way, our application is now calling and running the queries, but the queries are being called from somewhere else. They're more manageable somewhere else, so we don't have to search through all of our code base and figure out where the query is. We know all the queries are there, right? So we want to clean up those queries. We're going to search for any SQL that's inside of our code. We're going to move this statement and the relevant logic into gateway classes. Now, I'm not saying that's the end result, but it is the easiest way to clean up a legacy code base is to create some gateway classes and put your SQL out there for the interim, right? Maybe later on you want to get that more abstracted, but gateway classes are a good first step before you go into full abstraction of them. We want to create tests for these new classes now. We want to alter the code to use the new methods and then continue repeating until we've got all the SQL cleaned up and in gateway classes socked away somewhere safe so we know where all of it is. Then we can start searching for some other logic within our application. We want to extract our business logic so it's not intermingled with the view code and things like that. We want to pull it out. So we go through, we search for the use of gateway classes outside of transaction classes, and then we extract the logic to transaction classes. We test, we write new tests where they're needed, and we continue to repeat until all of our business logic is somewhere like our SQL. No cucumbers on a sandwich. Sorry about that. But that being said, we want to get everything nice and compartmentalized, right? We want to separate our concerns so So that way now we've got our logic here, we've got our SQL here, we've got our view logic here, we've got everything separated so it's much easier to test, it's much easier to find any problems, it's much easier to work within our code. And then we want to do one final search and look for any reading clues that might have been left behind. Right? There might be something stray here and there, so we want to continue to go through and search and clean those out, continue to refactor, backing up often, writing tests, committing things to our version control, make sure we have all these things separated out for us and all cleaned up. Use dependency injection where it makes sense and where we're able to, and repeat that until we have nothing left. We want to make sure we clean that up. This step's going to be relatively quick because now you've got your code base so clean that the include should just jump out at you and say, oh yeah, I need to get rid of that. Now some additional possibilities that would exist at this point would be implementing a framework. Maybe if you're not using a framework at this point, maybe it's just legacy code, chances are it's not using a framework. So now we can actually pull in Symfony or Zen or CodeIgniter or Laravel or whatever you want to. Now you can start leveraging some of that goodness that you haven't been able to leverage before because your code base wasn't good enough, right? Or the code base you're working in wasn't good enough. It may not be your code, but you've inherited it, right? You can also start leveraging services, leveraging events. So that way you can make your code base a lot easier to manage through services and events and be able to centralize some of that functionality and make it easier to manage. You can use Composer a lot more to pull in some of these frameworks and external libraries. You can pull in Guzzle to handle your HTTP requests. You can pull in other services like that, like templating, for instance, using Twig or Plates or something like that. You can pull those in a lot easier and now be able to really clean up your application and use some other code that is not your own. Again, I don't encourage the use of your own framework in your employer's applications. I don't encourage you creating an application and using it for your customers. Please don't do that. By all means, write a framework. I've written many frameworks, and every one of them sucked worse than using somebody else's, right? But please don't use it for the employer, because when I use a framework for somebody that's paying me to help them with an application, what happens when I'm not there? My number one job as a developer is to make myself replaceable. I want to be replaceable. Not only can I take vacation and be promoted with less pain, but it also is a good, responsible thing to do for my employers so that they can replace me if I get hit by a bus, right? If I'm using my own framework, how many developers are they going to be able to find that know Adam framework, right? None, because it's my own framework. But if I'm using Zen, or if I'm using Symfony, or I'm using Laravel, whatever the case might be, then that employer has a lot easier time finding a developer to replace me if something were to happen. Right? And that's why we want to use a framework. That's why we want to use a mainstream framework for our employers and our projects. The frameworks have gotten to the point now where they're much more modernized. If you're interested, come see my Zen framework talk tomorrow here. They've gotten much more componentized now. So if you want to use pieces of Zen framework, pieces of Symfony framework, pieces of Laravel, you can do that. You're not stuck with one full framework these days. That's usually a common response when I say use a framework, and they're like, well, I don't really like Zen, or I don't really like Symfony. But you don't have to use the whole thing. Use the good bits. Use the good bits, of each one. But by all means, use it. There are hundreds of developers working on each of these frameworks. You are not going to be as good as that 100 or more, right? It's just not going to happen. I'm not as good as 500-600 developers working on the framework. Okay, I'm off my soapbox now. I said enough on that. So why do we refactor? We refactor because we want to have less bugs. That's why we're modernizing our legacy applications. We want to have less bugs. We want to have faster development by having things more normalized, more compartmentalized. We want it to be more stable. We want to have easier onboarding of developers. When you hire a developer and you throw them into some spaghetti code, it takes so long for them to get on board, right? But if the code base is clean, it's much easier to get them on board. Because I entered that short, sorry. We could also save money, right? If you've got a good, clean code base, you don't need as many developers to work. You might not need as many servers to run that application. There's a lot of things that you can save money on with that application with a cleaner code base. That's one of the ways that you can sell it to your employer, right? Hey, I need to clean up this legacy code base. These are some of the reasons why. It also, so when do we refactor? We have to ask our boss, right? Or do we? I don't ask my boss. Refactoring is something I do. It's part of development. You want to leave your code base cleaner than you found it. Always leave it cleaner than you found it. And when you run across something that's kind of ugly, if it's close to something that you're working on, clean it up. It doesn't take long to clean it up. And it's part of development. You're already guessing on your estimates anyway. Why not just go ahead and take the extra time to clean some stuff up while you're going at it, right? And then just do it on your own. It'll make your life easier. So some challenges, right? We have to make sure we have manager buy-in. We also have technical challenges. There's a lot of technical challenges with refactoring and with modernizing. Right? There's a lot of things that we have to clean up. And maybe our servers don't support the latest version of PHP. Maybe we're not running the version of PHP that has, you know, namespaces or any of the other things, static types, or whatever the case might be. There's also social challenges. Certain developers might not want to do it, but you might want to do it. There's a lot of social challenges there, a lot of head clashing, a lot of head butting. When it comes to the boss, and it comes time to convince the boss, I'll just slide behind, sorry about that. When it comes time to convince the boss, there are three kinds of bosses. We have the tech-savvy boss, right? We have the quality-centric boss, and we have the time-driven boss. These are generally, most employers are going to run into one of these three categories. With the tech-savvy boss, it's easy to explain, right? There's less cyclomatic complexity. We want to use solid principles in our code, separation of concerns. We want to use an MVC framework. There's less bugs, easier onboarding of developers, right? The tech-savvy boss is going to get that. So it's easy to explain it if we have to tell our boss about it. With a quality-centric boss, again, very easy. Quality. Focus on quality with that boss. You know, hey, we're going to have better code quality. We're going to be able to have more tests. Our customers are going to be happier because our bugs have less bugs in them, or our code has less bugs in them. Customers are going to be able to request new features from us, and we're going to be able to create them faster. Right? That's some things that a quality-centric boss would look at, and maybe less bugs. A time-driven boss, this is the hardest boss to deal with. Because they want it now. And if you're refactoring, you're going to take more time. So emphasize features, faster feature delivery. You know, hey, we can get this out faster by doing this. We have higher productivity, less time reading code. We as developers spend about 60% of our time reading code. The other 40% is spent actually writing code. You have to read it in order to write, right? You can't add new features without knowing where you're going to add them. You can't modernize, you can't do anything if you don't read the code first. If you have a good coding standard in place, and if your code base is nice and clean, you're going to spend a lot less time reading code. Therefore, you're creating code much faster and for most of your time. Faster onboarding again. You can quickly bring a developer in, set them in a code base, and everything's pretty standardized and clean. It's much easier for them to become productive. I've been at companies in the past where it took 2 weeks for a developer just to get onboarded. You know, that was 4 days to get their environment up and running, and then another week just to understand how the damn thing works, or even just instantiate it, let alone work. You know, it takes time for that. Whereas if your code base is clean, you cut that time drastically.
It's more than 2 weeks. And if your code base is messy enough,
Yep.
that could be months.
Yep. And that's very true. I'm just using it as a ballpark. But yeah, I mean, these days you can use Vector to get development environments up and running. You can have a clean code base. You can get a developer on board in a day. The second day they're productive. You know, in a good, clean code base using some modern practices. There's no reason why you can't do that. And less debugging. You know, how many of you are really good at debugging? How do you get good at debugging?
Debug.
By writing crap. Right? You have to debug because you got to fix it, right?
Not
So
necessarily
that
yours.
being said, you know, if you're good at debugging, concentrate more on the code, cleaning the code up, and you'll have a lot less time debugging. You're not going to eliminate debugging, it's part of development, but you can cut it down significantly. Some concluding thoughts. First, do not refactor a broken application. If your application is broken, do not refactor. Fix the application first, then refactor. Now, I'm not saying that a bug is broken, right? A bug is just, I mean, it's a small inconvenience, but it's not a broken application. A broken application is it just doesn't work no matter what, right? Don't refactor a broken application. If there's a bug, sure, let's go ahead and refactor. It's just a minor bug, nothing big, you can come back and fix it later. Have tests in place. You have to have tests in place. Even if it's just a bulleted list of here's step 1, step 2, step 3, here's how I'm going, here's how I can test the code. In the perfect world, you have unit test or functional test or something like that, but you don't always have that in a legacy application. Do things in small steps. Love iteration. Do little pieces at a time. Don't refactor a great big thing, refactor small things. Test it, didn't work, now go do another small thing, and then keep on doing it. I thank you for coming and listening. Please rate the talk when I'm done. You can find out more about me on geekyboy.com. That's my personal blog. I post a lot of things out there. Also, you can see this talk recorded there. I've given this talk a few times, so it's out there recorded. Might even been better that I gave it today. Might be worse, I don't know. Go out there if you want to see it again, it's out there. As well as other refactoring talks that I've given are out there of how to do core refactoring, not just modernizing. I also have a podcast, Run Geek Radio, where I talk maybe a few minutes about running in each podcast, because I do run a great deal, and also about developing and best practices and things like that. So at this point, I can take any questions if there are any, or if you want to catch me offline, please tweet to me, whatever the case might be. Thank you for coming.
Where were the slides, you said?
I will link these slides from that joined in talk. I haven't done it yet. You can also do a search for me on SlideShare. All my slides are out there for all my various talks.
At what point would you take a look at changing the routing layer? Like I'm thinking of like an old app, legacy app, where say every page is a separate PHP file, right? Would you do that? Whether you do it in the framework?
I'm not against doing that. I'm not against having the old style 1 page per file, right? You know, where we used to have an HTML file and the PHP was in the header. There's nothing really wrong with that.
No.
I mean, it works. But so as we move forward in object-oriented, though, in the perfect world, you want that to be in some sort of browser where you can then say, if you type this URL into your address bar, it's going to go to this page. There's different ways to do that. I mean, there are different frameworks out there. Arta has a really great router that you can use. Zen Framework Router, Symphony Router. These can actually be decoupled and used in those instances. It's not pain-free, but you can do it. Right? I would encourage the use of those. I like using them because then you can completely manage your application's routing in the pages from within those files, the configuration files, right? And it makes it a lot easier versus having 1 page per file.
What point though? That's at what point? It's probably later on, right?
I think once you have your classes in one place, you can probably go back and do that. Now, realistically, I will tell you that I forget where Paul does it. Paul does it in the book that I recommended at the beginning, at mlaphp.com. In there, he does actually cover add and front controlling and the routes in there. I forget where he does it. I don't cover it in this talk because there's just not enough time in this talk to cover everything. But I would encourage you to check out that book. I believe he actually did a post on that mlaphp.com as well that says when front controlling can be introduced. So I recommend that. I don't have an answer for that.
Yeah, I just see that as one of the most difficult things because so many URLs
Definitely.
are all break.
Definitely. Now, once you've gotten to the point where you're refactored to the point where I got in this talk, it's easy to front control at that point. You know, but you know where to introduce it, the best scenario. I think Paul covers that. I just don't remember where he did it. Yeah. I'd encourage you to pick up the book if you have a legacy application. It's not an expensive book. It's only 250 pages, but it is step by step. you know, how I did here, and it's really great as far as walking this through.
Thought you were about to say it's only $250. You and I have different definitions.
Well, that may be too, but no, it's, I don't know how much he's even selling that book for now, but, huh? 40? Okay. Which is not bad at all. And you can probably read that book in a weekend. I've read it a couple of times in a weekend. And it really helped a lot. Good luck in your